Okay, now we have seen multiple ways of representing a digital circuit, a Boolean expression, a circuit diagram, a timing diagram, a truth table, a VHDL, black box model, etc. I did forget to mention two other forms of a Boolean equation that are useful to know, and that is called the compact minterm and compact maxterm form. So I'm going to pull up a page in the textbook that shows this table here. So here again we have all of our inputs listed from the 0th input to the 7th input. As you can see, the index showing 0 through 7. Now you also see the minterms, and the minterms are what we use for the SOP form, the sum of product form. So the minterms, this A naught and B naught and C naught, are what goes into the SOP form if we're looking for the ones in the circuit. The max terms here are used in the POS form, where we look for the zeros in the circuit. So these terms are what go into the POS form. So you can also represent your equation, as I did for our bacon ice cream chocolate syrup equation, using a compact minterm and compact maxterm form. So in the example that's shown here in the text, the compact minterm form would be all of the minterms that represent the ones in the circuit. Now we could go ahead and write out the full SOP form by writing out these three minterms, or we could write it's the sum of 5, 6, and 7. So if you look here, the result here shows the function in compact minterm form shows it's the sum, this is the Greek summation symbol, of minterms 5, 6, and 7. On the other hand, if we wanted the POS form, we could put it in compact maxterm form, which here this is showing the product of the max terms 0, 1, 2, 3, and 4. And again, that is showing where the zeros are in the circuit. And also you can see here the minterm form is the opposite of the max terms, and the max term form is the opposite of the minterms. So since we had 8 possibilities, we had 3 minterms, and the opposite of those would give us the remaining 8 minus 3, or 5 max terms. So if we were to write our circuit in compact minterm and compact maxterm form, let's pull up our previous truth table. You can see from our truth table, this is the 0th entry, 1 first entry, 2nd, 3rd, and 4th. So for us, in our compact minterm form, what would we get? I'm going to write it in red here. S is equal to the sum of 2, 3, 4. And in compact maxterm form, it's going to be the opposite of that, where the zeros are in the circuit, the product of 0, 1, 5, 6, and 7. And if you expand these out, you get what we did, the SOP form and the POS form. So it is important to know all of these forms and know how to go between all of them. So if you were given a timing diagram or a circuit diagram or a compact minterm or compact maxterm or truth table, you'd be able to go back and forth between all these forms and create all of the forms. So for example, I could give you the problem, maybe. There we go. I could give you to draw a circuit representation of the following. So draw a circuit representation of this F equals the product of 0, 2, 3. So what I would do to do this is I would first put this in my truth table. Draw a circuit representation, I'll say in SOP of this. Okay, so if I wanted an SOP, I know this is in a POS form. So I would first bring this into a truth table, figure out what my SOP form is, and then draw the circuit. All right, so we will be practicing that in class.